Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on LRU cache. So we have to design a LRU cache, and this is one of the most frequently asked problem. So let's quickly jump into the problem statement, understand it and start solving. Okay, last time we have solved the task scheduler. We'll mark it checked. You can find it in the list. Let's start with LRU cache. Okay, design a data structure that follows the constraint of least recently used LRU cache. Implement the LRU cache class. LRU cache int capacity initializes the LRU cache with positive size. Get returns value of key if the key exists, otherwise return -1. Put key value updates the value of the key if the key exists, otherwise adds the key value pair to the cache. If the number of keys exceeds the capacity from the operation, evict the least recently used key. The function get and put must each run in O of 1 average time complexity. Okay, now there are a few things that we have to incorporate. Okay, we can see we are put, get, and we are inserting capacity is 2, put 1, 1, put 2, 2, get 1, so we'll return 1 value for this key. 3, 3, 2, 4, 4, 1, 3, 3, 4. Okay, so what we basically have to do is we have to build a LRU cache. Okay, now what happens in LRU cache is it's like this, right? So you got a value, let's say 1, then you got a new value 2, then you got 3, you got 4, you got 5, right? But you have a constraint that your overall capacity is only 3 or only 4. So after having inserted 1, 2, 3, 4, 5, you insert 5, but the overall capacity has to be only 4. So you have to remove one of them, right? Now which one will you remove? As the name suggests, LRU is the least recently used. Since 1 was used least recently, because we use 5 is the latest, 4th is the next, 3rd, 2nd, so we remove 1. Okay, now again after this, let's say we got a number 2, size is full, we'll remove, but now 2 became the most recently one, right? So 2 gets updated and gets removed from here. So we didn't remove 2, we just updated 2, and now 2 came in the front of the list. Now we get a number 7, so we have to remove 3 and 7 is there. Okay, similarly if we get 5, let's say we get a 5 again, so 5 will be removed from this point and it'll be at the start, right? Okay, now there's a little twist. Rather than saving only the values, we have the key value pair. Let's say now we are going to store them in key value pairs, so both will go with this example. So first we got 1, 1, key is 1, value is 1. Then we got 2, 2, key is 2, value is 2. Then we got a get for 1, so we'll update 1 and bring 1 in front. So we'll remove 1 from here and we'll paste it here. Okay, then we get 3, 3, we'll put it in front. 3 is the key, value is 3. Then we get 4, 4, 4 is the key, 4 is the value. Then we get 1, so we have a get request, so we remove 1 from here and we paste it in the end. 1, 1. Oh sorry, we for this example we have the capacity 2, right? So we have to incorporate with 2. Let's start this from the beginning. We got 1, 1, so we entered 1, 1. Okay, we got 2, 2, we entered 2, 2. We got 1, get for 1, so key is 1, we got a get request, we remove it from the end and we put it in the front. Okay, now we got a 3, 3, we enter it in the front, that is 3 is the key, value is 3. But now the capacity has increased, right? So we need to remove the least recently used one. So we'll remove 2, 2 and 1, 1 and 3, 3 will stay. Now we got 4, 4, so we get 4, 4. Okay, we'll remove 1 since the capacity is 2. Now we get a get request for 1, but 1 is not available in our queue right now, right? So we have to return -1 in this case, as we can see here. Then we get a get request for 3, so we return the value for 3, which is 3, and then we update it in the front. We get a get request for 4, we return 4, we update it in the front. Okay, so this way it will work. Now the thing is, there's a chance. Okay, the thing is that we can understand that we have to store them. Also, we have to maintain the insertion order. So I'm going to provide a very simple solution for this one. Okay, you are going to love the solution, but as well as it will be much easier to remember it. Okay, we'll use linked hash map. So what linked hash map does is, first it's a hash map, so we have the fetching of the elements is in constant time, that is log of n, plus since it's linked, so we are maintaining our insertion order as well, so that it's always easier for us to remove the last or the least recently used one, right, or the oldest one. So with this, let's start with the solution. Okay, first we need few things. Let's for our LRU cache, let's define our capacity, private final int capacity. Okay, similarly we need a linked hash map, so private final map integer integer, since key and value are both in integer formats, we'll call it cache. Okay, now we only have to implement these 3 methods. Okay, we are calling the constructor LRU cache with the capacity, so we'll initialize the capacity. We'll say this dot capacity is equal to capacity, right? Then we'll use the linked hash map with access order to maintain our we'll use the linked hash map to maintain our insertion order. So we can say using linked hash map to maintain insertion order. Okay, so this dot cache is equal to new linked hash map. We need to pass the capacity. We'll pass the load factor 0.75. So load factor is the one which decides that when we have completed 75% of our, we have finished 75% of our overall available bandwidth, will increase the size of the hash map. Okay, now plus we'll maintain the insertion order, so we'll mark it true. This is to mark the insertion order in the this is to mark the insertion order, this is for the load factor, and this is the capacity for the linked hash map. Now what else do we need? That's it from this one, right? So let's implement our get key. Okay, so whenever we are seeing a key, we have to return if that key value pair exists in our map, otherwise we have to return -1. So we can directly use get_default method from our map for this. So return the value for the key or -1 if it is not present. Okay, so we can say return cache dot get or absent. So it fetches the value if it is available. In case it is not available, we provide a default value which is -1 in this case, right? So it will return -1 if the value is not available. That's it from the get operation. Now what are we going to do with the put? Simply first thing is we are going to add it to the list, so add it to the map. So we'll say or update the value if it already exists, update the value for the key in the cache. So we can say cache dot put key value. If the value already if the key value pair already exists, if the key already exists, it will update the value, otherwise it will insert this value in the map. Okay, but after this we have to check if we have surpassed the capacity, right? So we'll check if capacity is exceeded after the put operation. Okay, so we'll check if cache dot size is greater than capacity. Okay, so we can say remove the oldest entry, right? So we'll remove the oldest entry in this case. That can simply be done by cache dot remove. Now we want to remove the first one, right? The first one which was inserted, because every time when we are doing a put operation, it is getting updated, it is coming in the back of the line. So this, consider this is the start first and this is the end. Every time if we call 3 or if someone calls get on 3, we remove it from here, we enter it here. So this is the back of the line, this is the front of the line. This is where our first element is there. So we want to remove from here, so we'll say cache, that is our map dot key set. We'll use the iterator on this iterator, and the first one will be fetched by next. That's it. So we are saying cache dot remove, cache dot key set dot iterator dot next. It will remove the first element. So 4 in case if 2 came here, so 2 will be removing 4 from the starting side. That's it. That is the overall solution. If you see, this is very simple solution. We are just initializing the capacity, creating a linked hash map which is already maintaining the insertion order. We are doing the get operation with using get or absent so that we can return -1 in case it is not present. For put operation, we are simply putting the values and updating them. We are checking if it is surpassing the capacity. In case that is, we are removing it. We are removing the oldest entry. Okay, that's it. So let's quickly run it. Compilation error. CACHE line number 13, cache get or ABSENT. All these spellings are correct. What is wrong? Method get or absent, variable cache type max or integer. Okay, keys of type integer, int get key return c get or oops, it's not get or absent, sorry, it's actually get or default, not. So we do the get or we update the default value, not absent. Absent is not a method. Get or default. Okay, let's run it. Okay, great. Yeah, so this is get or default. So we get the value if the key is available, or we'll return the default value, which is this, and we can update it with anything. Since the required question says that we need to return -1 when not available, so we have set the default value to -1. Let's submit. Okay, so yeah, it means there might be fewer solutions, or there might, of course there are solutions more efficient than this one. This is the easiest one. One more thing, if you see the overall time complexity, it is going to remain constant, as we do not cover the time complexity of the internal linked hash map, how it is performing. So all the get operations and the put operations will be done in constant time. Well, that's all from today's video, everyone. For anything, please let me know in the comment section, and in the end, please like, share and subscribe. Thank you.